Okay, now we want to look at significant figures. So this is an important topic, very important topic in all science courses, because in all science courses we do measurements and we do calculations, and this is a set of rules that governs how many figures, how many numbers are significant in measurements and calculations. So first of all, we have to talk about measurement, because significant figures is very closely tied to measurement, and we propose that we can measure the same thing in different ways. Here we have a ruler that's in centimeters, right? This is a ruler that's in centimeters, even though it looks kind of large or small, depending on the screen size. It's in centimeters, we'll say, and it just has marking for every centimeter. So that's not very close. It's not very precise. But we can use a ruler, the second ruler, which has little ticks on it. Little ticks on it that should be millimeter tickings, right? So we can measure it with millimeter gradations. And here we have a calipers. The calipers is a highly precise instrument for measuring distance, for measuring the length of something, or the inside of a washer or something. Okay, so the thing with measurement is how many numbers you need to describe your measure. So if we're using this, we can say, well, it's 12 centimeters. And then we have to guess the third number. We have to guess, and we can say it's about 5. Looks about 5 from there. Okay, that's with the ruler with just the centimeter markings. Here's a ruler with the millimeter markings. Well, we can say it's well, it's a little bit less than 12.5, looks like 12.4, and we guess the fourth figure, right? So this is the issue of measurement, right? Is how many numbers you need to describe your measurement. And the calipers, depending on your skill in using it, and it'll give you quite a bit more precision. Let's say 2 more numbers. So it gives me 6 numbers. And so I'm measuring the same thing, but I'm just using different instruments and different ways to measure the same thing. So significant figures, as far as measurement, comes up quite a bit in the laboratory. In the lecture, of course, we just give you the numbers, but you have to come up with these numbers in lab. And so that's a part of it. But where significant figures really becomes more helpful in the lecture part of is in calculations. So there's a typical undergraduate experiment that works with weighs pennies and determines their volume and uses that to determine density. So if I have 8 pennies, I can weigh them, about 19 grams, and the scales typically are milligram scales, so they give 3 decimal points after grams. And so we can divide, if we want to know what is the mass of 1 penny, we can divide our measurement by 8. 8 is how many pennies we have, right? So I get a number, and this is what the number that I get if I plug this number into the calculator. Plug this operation into the calculator. I get 2.415625. So are all those numbers really significant, or are they not? Well, we don't know unless we have some rules to follow. Typically, they measure the volume of the pennies, right? You put them in a graduated cylinder and measure the volume. And let's say the volume is 2.24 milliliters as measured with your device. And the density calculation is simply dividing the mass of the 8 pennies by the volume of the 8 pennies. And here, if I plug this division problem into the calculator, I get a number with a lot of numbers, with a lot of digits after the decimal point. Are all of these really significant? Not sure, right? How do I know? Should I get rid of some of them? And you have to have some rules, right? And this is what significant figures tells you. It's how many digits, how many numbers are significant. And it also tells you the most important thing is what does the teacher want you to write down. So the first rule of significant figures is that all non-zero digits are significant. So if we go back from our previous one, 12.5 centimeters, I have three sig figs. Okay, so what is this stuff with figures, right? Figures is another way of saying number or digit or integer or numeral. So we count each digit, and we say that if each digit is significant, we have 3 significant figures. So a figure is another name for what we would probably usually call a number. This measurement has 4 significant figures, right? Because there's 4 digits that are significant, 4 non-zero digits are significant, and just to round things out here, the last measurement we made has 6 significant figures. Okay, so that's the easy one, right? All non-zero digits are significant, so they count as significant figures. The problem is with the zeros. Zeros can be significant or not, and we're going to learn what the rules are here. Zeros in front of non-zero digits are not significant. So here, the zeros, as remember, this is the radius of a gold atom. These zeros are not significant. So one way to kind of show this or get rid of the zeros is to write it in scientific notation. So we move the decimal place to the right 10 spaces, and so I can write this number in scientific notation. And since I moved it 10 places to the right, my exponent is going to be minus 10. And we'll keep the meters in there. And the beautiful thing is that all numbers, figures written in scientific notation are significant. So if I can successfully write the number in scientific notation, I have automatically the number of significant figures. But here the zeros in front of the number are simply placeholding it, putting it in that position, and we can get rid of those zeros by putting it in scientific notation and show or prove or demonstrate that they're not significant. But there's more rules about zeros, fortunately. Significance of zeros, zeros in between non-zero digits are significant. So here, yeah, there's some zeros out in front, but if I'm going to write this in scientific notation, I wouldn't take the 0 out of here, right? I would write 1.035 times 10 to the minus 7 meters, right? So I moved the decimal place to the right 7 times, so down right, the exponent goes down. And so I got rid of the non-significant figures out in front, but the 0 in between the 1 and the 3, I can't get rid of that, right? Because that's part of the number. Right, so that one I leave in there, and that's a significant figure, and this one has 4 significant figures. More on zeros. Wow, the zeros are pretty intense here, right? Zeros following any non-zero digits may or may not be significant. Okay, here we go. Here we get into it, right? First of all, it's the case where zeros at the end of whole numbers are not significant. So if my whole number is the distance between Earth and the Moon, I'm putting 5 zeros in there, but I don't really, those 5 zeros are really just placeholders. If I put this in scientific notation, I would get rid of these zeros by moving the decimal place over from way on the right to between the 3 and the 844. And I did it 8 times, right? So 8 to the left goes up, and scientific notation, I would get rid of those 5 zeros because they're not significant. But zeros at the end of decimal numbers are significant. So you can't say just that the zeros at the end of numbers are not significant, because it depends on if they're whole numbers that have no decimal point, or if they're decimal numbers. So if I have a decimal number, I think I have one here, 233.400, Um, I can still put this one in scientific notation, right? 2.33400, right? But I would keep those zeros. I can't get rid of them because they're part of a decimal number. And I'm doing it to the left, so it goes up. Right. So in the case of a decimal number, the zeros at the end are significant. Somebody put them there for a reason, because they're significant. Another issue that comes up is exact numbers, and exact numbers come up specifically in calculations. So there are exact numbers do not have a limited number of significant figures when used in calculations. So if you're counting how many eggs in a dozen, you count 12. 12 eggs in a dozen, and you can't have half an egg or a quarter of an egg, right? Or unless you have a hard boil it and slice it up or something. But 12 eggs in a dozen, right? That's a counting number, and so it's not a matter of measurement. I'm not measuring the number of eggs. I'm simply counting them. 3 feet in a yard is we call this a counting number. 3 feet in a yard is a conversion, is an exact conversion. So there are some exact conversions out there. And 2.54 centimeters in an inch is another exact conversion. Usually conversion between metric and English units are not exact, but this is an exception to that. Another exact conversion would be 60 seconds in a minute, right? So you're not really measuring how many seconds are in a minute. You're just saying this is a conversion. Or 4 quarts in a gallon, right? Another exact conversion kind of thing. So this will all become more clear once you start using these things in calculations, because there are rules about how to use significant figures, how to manage significant figures in calculations. But first of all, you have to know what significant figures are and when to judge that a number is significant or not. So we can see some examples of these numbers here, right? And count the number of significant figures. This one here, all are non-zeros, so it should be 6, right? 6 sig figs. This one here, we know that zeros in front of a decimal number, right? Those I can discount, and it's 2, 6, 2, 5. So 4 sig figs, right? Zeros in front of a decimal number are insignificant. Of course, zeros in front of any number are going to be insignificant. Here we have 2 zeros in here, but this is a tricky one, right? Because the zeros are between the 3 and the 5. So all of these numbers are significant, 4 significant figures. Ah, 6,000 hours. A lot of zeros there, but are they significant or not? The number doesn't have a decimal point, and the numbers are behind, just behind the 6. So all of these zeros are not significant, and there's really only one significant figure here. And here we're kind of mixing it up, right? We have 2 out in front here. I'm going to change colors. Going to get thicker blue. Out in front here, these are not significant. These are between the 3 and the 5, so they have to be significant. And this one's at the end of a decimal number. End of a decimal number, it is significant, right? So this has 5 sig figs, right? So now we understand, or we know, what significant figures are and how to identify a significant figure or a zero that's not significant, that can be dropped. And another key thing, right, is that by writing numbers in scientific notation, we write only significant figures in scientific notation. So that's a key fact to keep to keep a hold of. And thank you for your time.